guys. So keep studying our physics subject GRE. Our physics subject GRE. Okay, so 45. So 45. 48. 48. So basically, you see the question. Yeah, you know this question must ask you about special relativity. So basically, you have a rest time called tau, and then you also have you also know that you will keep running like 50 meters. So basically, you can compute the velocity because you have this. Basically, it's just v times the tau divided by this. Right, this is velocity. Velocity times the time, and this is the time time dilation. So basically, you can use this to solve v because you know the tau. Okay, so we have v over this. This is 15 over 2.5 times 10 to the negative 8. So this is 6 times 10 to the 8. So we have v squared c squared. C squared minus v squared. Probably is not correct. So let me change it to this square. Okay, how about we change this into c? So c is 3 times 10 to the 8. So this is so-called this is 2c. Okay. So we got the v squared c equals to 2c squared minus 2v squared, and v squared c plus 2 equals to 2c squared. So v squared v just equals to 2. Let me see. So vc times square roots. Basically, square root of c squared minus v squared. Okay. Yeah. So let me do this. I call it k. Okay. So v squared c squared v squared is k squared. So v squared c squared is k squared c squared minus v squared k squared v squared. So v squared just c squared plus k squared is k squared c squared. So v just c squared plus k squared 1 kc. Okay, so now which k is 2c. So this is 2c squared divided by 5 square root 5c squared. So one of this. Computational not efficiency. So the answer is C. Okay, 49. Basically, you have infinite xy plane and a second observer with x prime, and ask you about the electric field. And okay. So the difficult part is you need to remember when you do the x direction Lorentz force, then you will get this one. Okay, so for the basically for the magnetic field, you can go to a Wikipedia and find the true equation for the magnetic field. But what I want to say is that so when you do so in this example, the second observer has Vx relative. So he's asking about which of the following expression given the energy measured by the second observer. So second observer has the relative speed v to the first observable. So for the z, you just need this factor. So you just times the gamma times the gamma. Okay. So the answer is C. The answer is C. Okay, 50 in the initial frame, two events occur at the same time and 3c minutes. In inertial S prime, the same events occur at 5c. Means what is the time interval? Okay, so ask about the invariant. Invariant in a special relativity, which is dr squared minus c dt square is constant. Okay. So now the two events occurs and the time in instant in time and 3c minutes 3c minutes apart. So basically in the first you have 3c squared and this is 0. It will equal to the distance in the s this space-time distance in the s prime. So s prime you have the same events occur 5c minutes apart. So and y is the time interval. X is basically CT. Oh, so Pythagoras theorem tell you that this is basically 4. So the answer is 4c minutes. So answer we choose C. Okay, 51. Orbital for the Schrodinger for a particle in the box. Okay, so I already said many times, you need to remember the particle in the box. Remember the energy and then remember the wave function. This is so important that you have 100% chance that every time in the subject you are in physics, you will be asked about many questions, at least one question about the particle in the box. So just remember this formula is really important for you. Okay. Indicate the middle of the well, the probability, then vanish. Okay. Fortunately, this question doesn't ask you about how to do. Basically, if you draw the plot, then this ground state not vanish, second vanish, third not vanish. If you keep doing, then you know the fourth vanish. Okay, so the answer is 2, 4. So answer is all the other number. All the even number. Or if you don't want to plot, you can see this. So if I can plot L equals to 2, I get something constant times sine n pi divided by 2. So when n pi divided by 2 is equal to 0, means that n pi divided by 2 is pi times some integer. I call it m. So that means n is 2m. So it tells you that n is the even number. So if you do not want to make a plot, if you remember the wave function, then it's very good that you can still solve the question. So the answer is states of all even. States of all even. So the answer is B. So 52. Okay, so 52 is also asked about quantum mechanics. You have a rotator for what, blah blah blah, and ask you about the z component, which is possible z component. So you say that this phi is basically, if you remember clearly, this phi is basically somehow basically corresponding to the so-called spherical harmonics. So ask you about what is the possible z, and then this is y11. So the possible z is h bar or minus h bar. At least problem is difficult that if you don't know that this is spherical harmonics, then usually it's technical that it's very difficult for you to find answer. But probably this is y11 plus y this one. Or another way is that if you remember this, then you can act on this phi. So you know that what you need to do is you to expand this sine phi into this one. So you know that the possible eigenvalue for LZ stays this one and this one, plus or minus. And then there's h bar divided by here. So this h bar. So you need h bar or minus h bar. So the answer is C. So if you don't remember the spherical harmonics, at least you remember the form of the LZ differential operators. So either two of them can solve this question. Okay, positronium is bound. The electron positron continually stay at 0 orbital. So 0 orbital means L equals 0. Okay, so the most possible decay per down of any two such say plutonium with is basically asking about which photons. Okay, so remember photon has spin 1. So if your total angular momentum is your orbital momentum is 0, then you at least need to spin 1 to make a angular momentum conservation. So the answer just 2 photons to make conserve the angular momentum or the total spin. Okay, I think it's enough for today, and I will see you guys in the next video. And be sure to subscribe to my channel. Thanks.